Hello everyone, it's your favorite floating head, Mr. Wyatt. This is why you don't wear green t-shirts if you're going to be a weatherman. See, it's kind of cool. So we're going to do some quiz review here. First thing, let's just practice converting from degrees to radians. So remember, if you're trying to get rid of degrees, you want to put degrees in the denominator, and that means you're going to multiply essentially by pi over 180. Pi radians is 180 degrees. When you do this, the best thing you can do is leave the fraction alone, leave pi alone and reduce the fraction. So 35 out of 180 is that, which I will then convert to a fraction. I'm just reducing the fraction. You don't need a calculator, but this is 7 pi over 36. So you can reduce the fraction and then just leave pi alone. If you try and type pi into your calculator, you have then made the number irrational, which means the calculator cannot convert it to a fraction. So when you do this, you can't type in pi. Negative 140 divided by 180 is, I think that's 7/9. Yep, negative 7 pi over 9, negative 7 pi over 9. 265 over 180, 265 over 180. Math, frac, 53 pi over 36. 53 pi over 36. And then 92 over 180. Math, frac. 23 pi over 45. 23 pi over 45. So we're just converting from degrees to radians. You multiply by pi over 180. But when you do that, just ignore the pi. Just focus on reducing this fraction and then put your answer in terms of pi. So you do need to be careful that pi is part of the answer. If you're going the other way, going from radians to degrees, instead of pi over 180, we're going to multiply by 180 over pi. The pi is going to cancel out in these. You can see that they all have pi in the radians at the beginning. So the pi is going to cancel out, and I'm just going to multiply the rest of it. So I'm going to say 3 times 180, 3 times 180 divided by 13, which is, we'll say 41 point, it doesn't say how many decimals, so we'll just keep 41.5 degrees, 41.5 degrees. Now I could keep doing this. So 5 times 180 divided by 7. 128.6 degrees. 128.6 degrees. Negative 2 times 180 over 5. What you really, another way of thinking about it is you're replacing pi with 180 degrees. This is negative 72 degrees. And last one, 180 divided by 11 is 16.4 degrees. 16.4. So nothing too fancy here. We're just converting between degrees and radians. Multiply by either 180 or pi over 180 or 180 over pi. It just depends which way you're going. The other thing you might be asked to do is state coterminal angles. So for coterminal angles, you're going to add or subtract 2 pi radians, or 360 degrees. So if I'm trying to get between negative 2 pi and negative 4 pi, first thing, over 7, this would be negative 28 pi over 7 and negative 14 pi over 7. So I'm just multiplying 4 times 7 and 2 times 7 to get a common denominator. That helps me know when I'm supposed to stop. So I'm going to say 3 pi over 7 minus 2 pi would be 14 pi over 7, and that's negative 11 pi over 7. Negative 11 is not between these two numbers, so I got to do it again. Negative 11 pi over 7 minus another 2 pi. Negative 11 minus 14 is negative 25. And 25 is between 14 and 28, so that's my coterminal angle. I'm going to do the same thing here with negative 55. I'll use my calculator for that. So I'm going to say negative 55, and if you're in degrees, a full rotation is 360 degrees. So plus 360, nope, not enough. Plus 360. 665, still not enough. Plus 360. Hey, 1025, that's between 720 and 1080. So 1025 degrees, awesome. So that's just converting angles. Now let's actually use some of those things. We're going to maybe do some arc length and some area problems. So first thing, it says the length of an arc is, with an angle measure of 135 degrees, is 86 centimeters. What's the radius? So let's write, I like to draw a little picture here. Here's my arc. I can do better than that. How about like that? Hey, that's pretty good. We have 135 degrees. This is definitely not obtuse. And the arc length is 86 centimeters. So sweet, very well drawn to scale. We're trying to find the radius. Remember the formula for arc length is S equals R theta. We know S, 86. We don't know the radius, that's the unknown, and we know theta. But remember, theta is in degrees. These formulas only work if theta is in radians, so let's multiply by pi over 180. Now you can do it right here, or you can do it off to the side. If I don't necessarily care about the angle, I'm just going to do it in line, like this. But I do need to divide 86 divided by, that's not a 6, 86 divided by, and now you need to make sure you use parentheses, 135 pi over 180. We know that's actually 3 pi over 4. You don't even need to use the formula. So you get 36.5. R equals 36.5. And this is a length, and it is in centimeters, so the radius is 36.5 centimeters. Nothing too fancy. Let's try another one. The diameter is 22. What's the area? The area of a sector is 5 radians. So let's draw a circle. Okay, it's not the best circle. Let's do one more try. Okay. I can get a good one. Hey, all right. That's not great, but it's fine. All right, the diameter is 22. That means the radius is 11. That's what I really care about. And 5 radians is going to be somewhere down here. Okay, so we're going the long way. 6.28. Remember, 2 pi is 6.28. This kind of looks like a Pac-Man or something. Something's going on here. What else do we know? The diameter is 11. The area is 5 radians. So this is 5 radians. And that's all the way around. So 5 radians. So if we want to find the area of the sector, 1/2 theta r squared is the formula. We don't know the area. 1/2. We do know theta. Theta is 5. We do know the radius is 11. So this is pure calculator work. 0.5 times 5 times 11 squared. Now remember, 5 radians is not 5 pi radians. I didn't say 5 pi, I said 5. You're used to thinking radians is always going to be in terms of pi, because on the unicircle it is. But 5 radians is just an amount of radians. You don't need to convert that. There's no pi involved, so don't add pi. It's just 5. So your answer now is 302.5. 302.5 what? 302.5. These are inches, and since it's area, that's 2 dimensions, inches squared. So 302.5 inches squared. Let's do another one. We have a sector on a circle, so I'll draw just a sector. Again, it doesn't need to be to scale or anything. It's just to help you draw it. Radius is 14. The sector, so the area is what we do know. This area is 28 centimeters squared. This is 28 centimeters squared. And we're trying to find the angle. So we're trying to find theta. Area is 1/2 theta r squared. We know the area, 28. We don't know theta, but we do know r squared is 14 squared. So on the right side, I have 14 squared times 144. That's 72. 0.5. No, it's not. Half of 196. So it's going to be 98. So this is 98 theta on the right. 28 divided by 98 will get you theta. That's 0.29. So 0.29. And you got to know that theta is in radians. So 0.29 radians. 0.29 radians is not a lot. Let's see. Linear and angular speed. All right, so the wheels on Benny's toy car have a radius of 3 centimeters and they're rotating at 400 RPMs. So remember, if you're trying to find the linear speed, well, we want both. So let's say first we'll do angular speed. Angular speed is theta over time. So if it's 400 RPMs, 400 revolutions, and each revolution is 2 pi radians, that's 800 pi radians. And the time would be, they didn't give me a unit, so we'll just say it's RPM, so per minute. 800 pi radians a minute. That's the angular speed. Now let's find the linear speed. So when we do that, we just multiply by the radius, 3. So 300 times, or 3 times 800 pi over 1 minute. Let's see, this is going to be centimeters. Let's go centimeters a second, so 60 seconds. Okay, I'll normally tell you what I want your units to be, but I'll just say I want it to be centimeters a second now. So instead of 1 minute, I'm going to put 60 seconds, and now I just type this in my calculator. 3 times 800 pi, make sure you use the pi button, divided by 60 seconds. And my answer will be in centimeters a second. So 125.66. This is nearest hundredth. 125.66 centimeters a second. What is this? Get out of here. Okay. Unless I tell you different units, I mean, I'll tell you what I want generally, so you'll know. But here, let's just say centimeters a second. How many revolutions will a tire make? So this is where you can use a formula, but sometimes you get hung up on a formula. Let's just think about kind of what we know. We can figure out what one revolution would be. Okay? And we can figure out how far we need to go. We just need to figure out how many it's going to take. So the first thing we do is figure out what's one revolution. Well, if you're trying to figure out how far a tire goes in one revolution, that's its circumference. So that's pi times diameter. This is 24 pi inches. So that's like, I don't know, 24 times 3 is 72. So let's say it's like 75 inches every time it goes around. I mean, you can just actually type it in, 24 pi. Every revolution, oh my gosh, you're a math teacher. 75.4 inches every time you go around. Well, how far do you got to go? You got to go 2 miles, and each mile is 5,280 feet, and each foot is 12 inches. So we're going to say 2 times 5 tomatoes, 5280, times 12. That's how many inches we're going. And we're going to divide by how many inches each revolution is. And I'm going to get 1,680.7. 1,680.7 revolutions. So it's going to take 1,680.7 revolutions doing this distance to get that distance. So sometimes the formula isn't really necessarily the most important thing. It's more about kind of using your brain here. We got one more. Suppose the truck is driving down the highway with a speed limit of 55. The driver's pulled over for speeding. He's got a 36-inch diameter going 600 RPMs. So he wants to know what, he's like, hey, I wasn't speeding. I know what my RPMs were. I know how big my wheel was. I wasn't speeding. So we'll say the speed is R theta over time. The radius is 36. Nope, the radius is 18. He's going 600 RPMs, so 600 times 2 pi is 1200 pi. And we got to think about our units here. We need to get to miles per hour. Right now we're in inches per, let's just go to, I guess we could say per hour, and we can convert to miles without too much effort. So we'll say this is inches per RPMs. So we'll say per 1 minute. 1 minute. Okay. We're going to have to convert that though, because we're trying to get to miles per hour. Right now we are in inches per minute. So we're going to have to convert the time, and we're going to have to convert the distance. So this is dimensional analysis. So first, let's do the time. There are 60 minutes in an hour. So 60 minutes. I'm trying to cancel out minutes, so I'm going to put minutes on the top. That way these cancel out, and now I'm in inches per hour. So I don't want inches either. If I have inches in the top, I need to know something about inches. You might know inches in a mile, but I'm just going to say inches in a foot. There are 12 in a foot. And then one more thing I got to do is convert feet. So, oh, that irritates me. If I'm trying to cancel out feet, I'm going to put some feet on the bottom. And I'm like, okay, well, let's say 1 mile is 5,280 feet. So now I can type all this in my calculator. So it's going to be 18 times 1200 pi. Is that everything in the top? 18 times 1200 times 60 divided by, and when you do this, make sure that you put all those values in the denominator. 12 times 5,280. Is that everything in the bottom? Yep. And I get 64.3. So this is 64.3 miles per hour. So my question is, he's like, hey, I wasn't speeding. Speed limit is 55. Wait a minute. Yes, you were. You're going 64.3 miles an hour. You're 9 miles over the speed limit. You're getting your ticket. Okay. So we can try and go through this and figure out how fast he was actually going. It's like, well, you don't have a case, bud. You were speeding. So that's it. Go ahead and get your checkpoint done. Make sure you hit that like and subscribe.